over my shoulder here, this is an example of a chemical or a chemical equation. And you can see that we have water on this side, and then we have some combinations of atoms on the other side. And remember, we had said, what was hydrogen? We had said hydrogen consisted of one proton, and we'd said you had the same number of electrons as protons, so one electron. And there's no neutrons. So hydrogen is just a proton and an electron, and we had said we have the oxygen, which consisted of 8 protons and 8 electrons. Now, the chemical reaction up there, if you look at it and think about it, you say it looks like water is breaking apart. And it can, and it does this. And so if we remember what hydrogen is, just a proton and an electron, if it breaks apart and we end up with H positive, now what did we say positive means? That's a cation, it's lost an electron, right? And the anion, we have OH negative, and that would be an anion, meaning it's gained an electron, right? So what do we have left? So if we look at it pictorially down here, we'd said this is what a water molecule looks like, and we'd said if this hydrogen loses its electron, and that's the extra electron there, what's left? Just a proton. So we have a proton here, and then OH, oxygen and hydrogen, with an extra electron. And that's what we've drawn up here, a cation and an anion, and water does this. It does this very rarely, though. It does, and so we'll get into how rare here in a few minutes, but it does this naturally. And we've said water is the natural solvent for life. When we looked for life on Mars, one of the things we have to find is water. If you don't have water, you're not likely to have life. So I said we're segueing into a discussion of acids and bases. So if you look at your PowerPoint, you can see an acid is a proton donor, and we have some examples, hydrochloric acid and sulfuric acid. And you can look at those chemical reactions, and you can see that we have some H pluses. So in the acids, we're not talking about water, but acids, this is the same thing that an acid does. And what does an acid do? It releases a proton. And in the case of acids, they just break apart. All of the hydrogens in them are protons. And so they break up into these cations and anions. And we had said that what drives chemical reactions is a desire for stability. Those protons are not stable, and neither is the anion, and so they're highly reactive. So if you get an acid on you, you want to wash it off, or a base, either one, you want to wash it off. And so a base, so when we talk about an acid, it's actually, by the way, foods that are acidic have a sour flavor to them. And when we talk about bases here in a few minutes, we'll talk about how they have a slippery feel. But regardless, either one, they're both highly reactive, and they both will essentially burn you. So what is a chemical burn? It's where you have a chemical reaction happening on your skin. So we had said an acid is a proton donor, and then we have this other thing, and it is what we call a base, and it's something that will grab up protons. Before we really get into the discussion of the bases, though, I want to continue thinking about these protons. So you might know a little bit about chemistry or acids and bases, or maybe you've just heard it on television, but you might know there's something called the pH scale. And the pH scale is, P and H stands for something. So the P stands for proportion, and the H stands for hydrogen ions. The proportion of those hydrogen ions, those protons that are found in the water, in the solution. That's what the pH scale is about. And I've gone 6 minutes. I'm going to stop here, and we're going to talk a little bit more about this as we explore the pH scale.